Good morning on this fine snow day once again. I want to discuss problems 10, 15, the 18 with you prior to your 10.1 quiz that you need to take today. This is an exploration about our confidence intervals and the effects of sample size and confidence level on your margin of error in a confidence interval. In the first problem on 1015, I started on page 637. I have my calculator with me. Confidence level and margin of error, it's called. We're told that we are dealing with a population that follows a normal distribution with a particular mu that we want to estimate, and the average of interest is the SAT math score of high school students on their second attempt at an SAT. So we're interested in the mu, and we're told that the standard deviation of the population is 50. So what we have is a sample mean resulting in an X bar of 22, and that was based on a sample size 1,000. Part A wants us to construct and interpret a confidence interval based on a 95% level of confidence. And so for our interval, we are going to use a subscript of 95 to show we have an X bar, our sample mean, of 22. And we're going to add and subtract to that the critical value of Z related to 95%. I'm going to actually go to the back table in my book because the critical values are listed on the bottom of my T table. 1.960 is the critical value of Z. And my standard deviation was 50, and I'm going to divide that by the square root of 1,000, the sample size. So, first piece that I'm going to do is the 50 divided by the square root of 1,000. And that's about 1.58. So my confidence interval is going to be 22 plus or minus 1.960 times 1.5811. I'm going to leave that value in my calculator, and I'm going to multiply it by the critical value. So I'm dealing with a margin of error of 3.099. So when I take 3.099 and I add that to 22, I get my upper end of my interval at 2.099, and when I go back and I subtract that from 22, I get 18.901. So the interpretation of this would be, I am 95% confident that the true mean math SAT score for a high school student is between, taking it the second time, is between 18.9 and 25 based on the method I used to obtain the sample. So construct and interpret, calculate the 90% and the 99% confidence intervals for this mean. The intent of this is to see what the sample size does. I'm sorry, the confidence level does on our margin of error. We're interested in a 90%. I'm going to do 22 plus or minus. I'm going to go grab that critical value of Z, 50 divided by square root of 1,000, and I'm going to also construct a confidence interval based on 99%, 22 plus or minus. Need the critical value for 99, 50 divided by the square root of 1,000. So when I go and get my critical values for 95 and or 90 and 99%, I'm looking at 1.645 and 2.576. 1.645. Now, in order to expedite this process, I'm going to use my calculator because I have all the details of the interval. I'm just going to let the calculator do all the legwork for me. I'm going to enter in my statistics. My sigma is 50. My mean is 22. My sample size is 1,000. And I actually have it set to 99, so let me run that one real quick. So this is going to be the interval 17.927 to 26.073. When I run my test again, I'm going to just change my confidence level to 90. And my interval is from 19.399 to 24.601. So let's take a look at a comparison. We need to have a sketch. I'm not going to pause on the sketch. You need to pause on the sketch. When my confidence level was at 95, I went from 18 to 25. When my confidence level was higher, my interval got wider. It expanded. The widest interval came from the highest percentage. The more confident I want to be, the wider my net needs to be. Looking at 16 is dealing with the SAT again. And in this case, we are going to now change our sample size. What we dealt with the 95% confidence level in our last problem is going to be relevant to this problem. We're going to do the same calculations. Confidence interval at 95%, 22 plus or minus 1.960, the critical value of z, 50 divided by, and at this point I'm changing my sample size to 250. We move on in this problem and change our sample size to 4,000. So we're exploring the effect of the sample size on your confidence level. Or I'm sorry, your margin of error. And then, last but not least, I don't want to forget, in part D, we have to figure out a desired sample size. I'm going to again let my calculator do the work for me. Stat tests using a z interval. My statistics are there. My sample size needs to change. 250. 95% confidence. And I'm looking at 15.802 to 28.198. Sample size went down from 1,000 and the interval got wider. Sample size went down, the interval is wider. And I'm comparing that back to my interval that I had with a sample size of 1,000. Run the test again. Change my sample size to 4,000. 20.451 to 23.549. And what I expected. The interval went up. I'm sorry, the interval got narrower when the sample size got up. The sample size went up, we have a narrower interval. I am more sure when my sample size is larger. Now, last question is what's the desired margin of error? How is this written here? I want to be 95% sure, which means I'm going to be dealing with a critical value of z for as 1.96. And I want my margin of error to be plus or minus 2. I want it to be no greater than plus or minus 2. So I have a formula that I have written down, grab it out of your book, about how to calculate your desired margin of error. So I'm going to go back, and my statistics, I had 50. And the sample size is what I'm interested in if I want to keep this under 2. So I'm going to place some algebra here. I'm going to I'm going to divide both sides by 1.96. I'm going to multiply both sides by the square root of n. Put that on the denominator of this fraction. I'm going to divide by 1.02. And then I am going to square both sides to undo the radical. So doing that produces my n needs to be larger than 2401. There's two other problems in this setting, 10, 17, and 18. You can check 17 in the back of your book and discuss 18 together. I'm interested in you having a discussion with each other regarding what the purpose of the problem is and what it reviews in each of those cases. For your quiz that you're going to take, remember to use your calculator's stat, edit, and list function to enter data to produce your sample mean. And then in your stat test menu, you'll be able to tell your calculator that you've entered the data into your list. And it will use that to help you build your confidence interval. Good luck.